Hello students, now we will discuss about the graphical representation of describing a motion. In our previous class we know about that particular thing slightly. Now we will discuss elaborately on this matter. So as we actually know that there is two axes along this is a vertical axis or y-axis and this is your x-axis. So this is your x-axis, this is your y-axis. Now along x-axis always time is plotted. So along x-axis time is drawn. Now along y-axis there are three factors. One, either distance or displacement. Number two, speed or velocity. And number three, acceleration. So there are three different quantities, physical quantities, which we can plot along y-axis. One is distance or displacement, another is speed or velocity, or acceleration or retardation. So these three quantities, each of them, if we draw this kind of graph, then it is plotted along the y-axis. So first of all, we can actually draw the distance time graph. This kind of graph is said to be distance time graph. Mind it, for the graph plotting, we have take equal interval. Suppose those are equispaced with each other. These are equispaced as along, just like the graph paper, along y-axis. This is an equidistant some point like this. This is the starting point, or it is called 0, 0 point. This is along x-axis, this point is 0, along y-axis this point is 0. Now take a one step, 1, 2, 3, 4, and along this 1, 2, 3, 4. As you require. As your requirement, you can draw this consecutive term. But mind it, these two axes have an equidistance or equispaced points. Now along this axis, x-axis, if time is plotted, then the unit is second. So this is 1 second, 2 second, 3 seconds. So along this x-axis, second is the quantity, physical quantity. As it is a time, the unit is second. Now as it is a distance, in case of SI unit, it is in meters. So along this axis, these points 1, 2, 3 magnitudes are same, but the unit is different because it measures the distance. So it is an m. Now if we plot a certain kind of graph like that, this is a kind of graph in which we can say for 0 time the body is at 4 meter distance. Now for t equal to 1 second, the body is again 4 meter distance. So the body doesn't change its position irrespective of anything. That means that body is not time dependent. So distance time graph, in this case, this graph in a distance time is nothing but the body at rest. So this is the case where body at rest. So if we plot this kind of graph, distance time graph, then this is a body at rest. This graph is body at rest. So whenever body is at rest, then the graph is like that. It is parallel to the time axis if we plot distance time graph. Now if the graph is like that, it is like that. It's a straight line passing through origin. If we plot same quantity 1, 2, 3, 4, etc., and 1, 2, 3, 4, etc., at that distance, this is the distance and this is the time. If we plot that kind of quantity, that means at 1 second the distance is 1 meter, at t equal to 2 seconds distance is 2 meter, at 3 seconds distance is suppose 3 meter. So here the body changes its position continuously. That's why it's on a curve which is a straight line passing through origin. Now each of them, if we draw a rectangle, a triangle like that, if we draw a triangle at that particular point, then it is on a right angle which is 90 degree, and these two with respect to that angle, this is called the height of the triangle and this is the base of the triangle. If we plot this height by base, if we draw, and that quantity is called the slope. So slope is nothing but height by base of a right angle triangle. So this is a right angle triangle whose height and base are given. Now if these two height is nothing but the distance, so it is a distance, and base is nothing but the time. So distance by time, that would give surely the speed. So if we plot distance time graph and we can calculate the slope of the curve, then we can get the speed. So from the distance time graph, if we plot and if we calculate the slope of the curve, we can get the speed of that particular body. So this is the significance of distance time graph. Now if the distance time graph is like that, if the distance time graph, it is on a distance and this is the time axis. If the distance time graph is like that, then every moment this triangle should differ. Its height and base should alter. So at every moment the height by base ratio is changing. That's why if height by base ratio is changing, that means the velocity or the speed should be changed. So it is a body with variable velocity. So it is a body with variable velocity. So this is a kind of graph that can represent the body with a variable velocity. So the body with variable velocity have this curve shape curve. So the first one is the body is at rest. This is the distance time graph. The second one is called body with uniform velocity, with uniform velocity, and the third graph is body with variable or non-uniform velocity. So this is the body with non-uniform velocity. This curve that is actually the curved surface, that's why it is the body with variable velocity, and this is the body with uniform velocity. In this case, particularly in this case, the body have zero acceleration, but in this graph, as the body with a variable velocity, that means here acceleration is present. That means acceleration is present. As acceleration is present and there is no information about that, from that graph we can't calculate the value of acceleration. That's why we have required to draw another kind of graph, which is a speed time or velocity time graph. In our next class we can discuss about that. Thank you. Stay home, be safe.